Hi, everyone. This is my Lab 4 report. This is a quick overview of what I'm talking about today, starting with the introduction. So first, the purpose of the lab is to predict behavior of circuits with resistors in series and parallel, use multimeters to measure the actual values of current and potential difference, and examine behavior of resistors and capacitors. So some of the physics principles utilized is Ohm's law, where the electric current is proportional to voltage and inversely proportional to resistance. Capacitance is the ability of a system to store an electric charge, and loop rule is the total potential difference of a circuit path is zero, and the node rule is the current inflow must equal current outflow. So a quick overview of results is that when you reverse connections to an ammeter, the sign of the current actually flips, and the round trip potential difference is zero, and we actually measured this. And in RC circuits, capacitors require time to charge, and the magnitude of the current depends on how much time has passed. So quickly moving into the experiment, we see that initial conditions don't really apply, but the circuit is the system and surroundings are none. And part one of the methodology, we download the circuit construction kit and construct a circuit with the following specifications. And we predicted the current to be 0.0204 amps, but the actual current was 0.02 amps. And we found that when reversing the connection to the ammeter, the actual current changed sign. So moving into part two, we replaced one of the ammeters with a voltmeter, removed the voltmeter from the circuit, closed the circuit, and then used the voltmeter to measure potential difference for each part of the path around the circuit. And so when we replaced the ammeter with a voltmeter, we found that the predicted and actual voltage were the same. And then when we calculated potential difference in each part of the path around the circuit, most of the values were zero, a couple had actual values, and according to the loop rule, the potential difference for the entire circuit should be zero, and our results actually support this. And so in part three, we first connected the voltmeter across the 100 ohm resistor, replaced the voltmeter with an ammeter in parallel, and then calculated the resistance of each of the following circuit elements. And so answering the question of what happens to the current through the other ammeter, we see that it actually increases since the resistance decreases. And then we also have the values listed below for the resistance of the 47 and 100 ohm resistors, the wire and ammeter. And so in part four, we do RC circuits where we construct the circuit with a 10 and 20 ohm bulb, 9-volt battery, and a 200 mF capacitor. And then we observe the light produced by the 10 and 20 ohm bulbs, disconnect the battery and connect the capacitor directly to the bulbs. And then we also look at what happened to the current in the circuit when we connect the battery and when we disconnect it. And we measure the time it takes in seconds for capacitors to charge and discharge using both bulbs. And then the results from this portion is the light is actually behaving the same when the battery is connected and disconnected. So it starts bright and eventually goes out. And then same goes for the current when it's connected versus disconnected from the battery. So it starts at its maximum and decreases over time. And we also see below the time it takes for the capacitor to charge and discharge using the 10 and 20 ohm bulbs. So in part five, we set up a circuit with a 9-volt battery, a 200 mF capacitor, and a 30 ohm light bulb, measured the voltage across the capacitor, set the capacitor to discharge, and then found voltage versus time data and a plot, and then used the plot to calculate RC. And so this is actually the data collected on the left and the plot of that data on the right. And so using the equations on the right of the screen, we actually were able to calculate the RC, which is 6.752 seconds. So some possible sources of error could be that the RC is inaccurate because I rounded some values in the data collection, and then the time it takes for a capacitor to charge and discharge may vary depending on the setup of the circuit. And so moving into the what if questions, the first one, we see that real ammeters actually have resistance, meaning the readings would likely be less accurate or precise since we are using an ideal one in the experiment, which allows us to have more simple calculations. And so moving into the second what if question, if we used a battery to charge a real capacitor with no resistor, we could predict that the capacitor would instantaneously reach full charge, but this probably wouldn't happen in real life because almost if not all parts of the capacitor, including wires, would actually need time to charge since they all have some sort of small resistance at least. Thank you.